The Physics Nobel Prize of 1954 was shared by Max Born and Walther Bothe. Firstly, I'm going to talk about Max Born, who won the Nobel Prize for the seminal interpretation of the wave function. He was a German physicist and mathematician, born in the 2nd of December of 1882, Breslau, Germany, and died in the 5th of January in 1970 in Göttingen, also Germany. In addition to quantum mechanics, he also made contributions in solid-state physics and optics. When he was a professor of theoretical physics and director of the new Institute of Theoretical Physics at Göttingen, he formulated the now standard interpretation of the probability density function in the Schrödinger equation of quantum mechanics, published in July of 1926. For all this, we can say that he is one of the fathers of quantum mechanics, and he had a friend relationship with Albert Einstein. The seminal interpretation, when he won the Nobel Prize, it's a statement as to a minor wave function interpretation, so it tries not to make the fewest assumption with the standard mathematical formalization. It states that the wave function does not apply to an individual system, only to an ensemble of similarly prepared systems. Albert Einstein supports this theory, and in his works, the attempt to conceive the quantum theoretical description as the complete description of the individual system leads to a natural theoretical interpretation, which becomes immediately unnecessary if one accepts the interpretation that the description refers to a ensemble of systems and not to individual systems. After Max Born, some other physicists made statements about the seminal interpretation, as John Wayne, who said that the quantum wave function was related to a probability of getting a particular experimental result when one of the members of the ensemble is selected by an experiment. But he added that there were many difficulties with that. Other case was Willem de Muynck, who describes an objective realistic version of the seminal interpretation. He claimed that the values of the quantum mechanical observables may be attributed to the object as objective properties the object possessed independent of observation. The seminal interpretation had application in theories as the single particles, in the Schrödinger cat, and in the quantum zero effect. The other physicist winning the Nobel Prize was Walther Bothe for the coincidence method. He was a German nuclear physicist, born on the 8th of January in 1891 in Orenburg, and died at the 8th of February in 1957 in Heidelberg. He joined the Laboratory of Radioactivity at the Reich Physical and Technical Institute. After taking part in the World War I, he came back and he developed his theory of the coincidence method in 1923. He had implemented the coincidence method in experimental of quantum scattering. It was done to check whether quantum scattering produces a recoiled electron simultaneously with the scattered gamma ray. He used two discharge counters connected to separate 5 electrometers and recorded the deflection on a moving photographic film. He could discern that the coincident discharges with a time resolution of approximately 1 second. The coincidence method, why he won the Nobel Prize, is based on the use of coincident circuits and permits establishment of the time relations between various correlating events. One of the principal methods of establishing the sequence of appearance of secondary particles and gamma quanta is to register coincident electrical signals from nuclear reaction detectors. He was the first of investigating the coincident method, and after him, Coulter and Rossi investigated it also. It has practical use in the nuclear field, to presuppose knowledge of coincident curve, to know the circuit output signal of the time relation variation T between electrical signals, and also the effect of false coincidence on the registration of nuclear interaction can be sharply reduced. And for all this practical use is used the corona reflection light.